So here in this exercise, we want to differentiate between what happens in a material which has very good conducting properties versus in a material that has insulator-like properties. The basic idea is that in a conductor, very broadly speaking, we say there is only a conductor and an insulator. In a conductor, charges are free to move, so they're very mobile. So, and in the extreme limit, they are completely free to move. So, if there is a force on it, they will move. Insulator, even if they do not like it, they are not free to move. In the extreme case, they are completely free, not free to move. What that uh, means to is that if you had uh, or just a sphere or a material of any shape and you had just barely two electric charges on it, two positive charges, in a conductor, they will stay away from each other as far away as possible. So this happens in a conductor, so they will stay as far away as possible and they will minimize the energy in that process. In the in an insulator, that's not a choice. If they have been placed close to each other like this, they cannot move around, so they are stuck with that situation. Remember, positive charges repel each other and they would like to stay far away as much as possible. But that's possible only in a conductor, they will do that. But in an insulator, even if they would prefer to stay away, they cannot. So that's a basic idea. And what that amounts to is that if you bring in two conductors, then the charges will redistribute themselves and stay as far away as possible. Or in very simple terms, if they are identical spheres, then they will just share the charges. So that's the basic idea that's going on. So let's show that here. So let's say there is a charge sphere labeled A, then there is a charge sphere labeled C, and there is another sphere labeled A. They are all identical. That means to say that if you had some charges, they'll be equally distributed on all of them. Let's say to begin with, there is a charge on A, which we will call Q of A, and that's Q itself. Let's say it's positively charged, even though it's not clearly said that it is positive, it just says it's identical, equal charge on both A and B. So let's say it is positive Q. Q on the charge C is 0, and charge on B is identical to A, so it's plus Q. So that's a scenario, and they're all far away. They have finite distances between them, but it's understood that C is not affecting A and B in the sense that it is not polarizing the charge. So this positive two charges, if I have another charge here, that can affect it this way, try to move the other way. So basically what we are saying when they're far away is that the presence of C is not disturbing the configuration of charges on A and B. That's the idea of saying that it is they are far away from each other. Before we proceed and say the C touches A and B, let's go ahead and calculate what is the force between A and B if C was not there. And it is practically not there because its charge is 0 at this stage, but even otherwise, we're saying it is very far away, so that charge is not affecting it. So the force on AB, which, uh, so this is force between A and B, the magnitude of that is equal to K times charge on A, that is Q. Let's say Q of A, let me write that like that. Charge on B, that's QB. And let's say the distance between them is D squared. All right. And this, we are told, is F, right? In part C, it is mentioned that this is F, right? So that's our original scenario. This is where we uh, begin with, and let me call this the initial state, just to clarify. Now, afterwards, a third identical conducting sphere C is uncharged, and sphere C is first attached to A. So let's talk about the situation where C is brought closer to A and it's touched to A and then taken back very far away. So this is the situation after C has touched A. All these are conductors, so by touching it means that the charges are free to move around, they redistribute themselves, and by redistributing, we mean that the charges average themselves out. So, what's the charge on A after it has been touched? So, let's call it the prime charge. So, this is prime now, and that will be equal to QA plus Q of C, whatever charge was on A, whatever charge is on C, doesn't matter whether it's positive or negative, and then they redistribute themselves. So that's put them all together and then divide by 2. And the same thing, QC is now shared, so that's QA plus QC over 2. The charge on B stays the same. It is not being touched by C. It stays. It doesn't participate in this game at all. So it stays Q of B prime. Just stays the same. So it's Q of B. Let's calculate this. A was Q. C was 0. So that's Q over 2. This is equal to again Q over 2. This does not change. So it stays Q. So that's the situation. That's the amount of charge that's in here uh, after C has touched A. But then we say that C is next touched to B after it has been touched to A. Now with this configuration, uh, now it is touched to B. So after C has touched B, right? That's the second situation. So this, if you want, tells us no, we are not yet in the process of work answering the problems. This is just going through the procedure. When C is touched by B, the charge on A stays the same. So now let's call it the double prime. So that's a new charge. That's uh, a new configuration after charge or the sphere C has touched B. So this stays the same as original A, and C and B share. Right? So this will be QC prime plus QB prime over 2, and here it will be QB double prime will be QC prime plus QB prime over 2. How much is this? A prime was Q over 2, doesn't change, so that's Q over 2. Here now it is the prime charges on C and B has to be averaged, so add Q plus Q by over 2, that's 3 over 2, and then divided by 2, so that's 3 over 4 of Q. And the same charge is 3 over 4 times. A good check is that the total charge doesn't go anywhere. So there was a total amount of 2Q of charges to begin with, which was distributed on A and B equally. And that stays the same at each step. Here it is 1 by 2 plus 1 by 2 plus 1, that's 2. And now it is 1 by 2 plus 3 by 4 plus 3 by 4, that's again 2. So the total number of charges doesn't go anywhere. They are only redistributing themselves. At this point now we can ask, so we can start answering the questions. What is part A? Part A is that at this stage, after these two processes has been, procedures has been done, what's the charge on A? As a result, what is the charge on A? If it was originally Q, we started with Q, And after the two steps, we have charge Q over 2. So that part A problem is Q over 2. How much is the charge on B? That's part B. And that's 3 over 4 of Q. And coming to part C, originally the electrostatic force between them was F, which is basically QA QB over 2, which is equivalent to saying F is equal to K A and B, charge on A and B was KQ square, right? So it's Q and Q square over D square. That's your force F to begin with. But after this process of C touching A and then touching B has been performed, what is the new force? So that will be F double prime now. So it's F double prime. So let me do that here. So this is F double prime of AB is equal to K times QA double prime times QB double prime. The distance remains the same, so it's distance squared. QA double prime is half of Q, so it's half. A factor of half comes from here, 3/4 comes from there, so I write that separately, and that is KQ square over D square, which is 1 by 2 times 3 by 4 is 3 over 8 of KQ square over D square is just F times F. So it is no more the original F. It has decreased, the force has decreased significantly because of this process of touching uh, two times, once A and once B, right? So it's 3 over 8 of the original force F. This clarifies how electric charges moves around on materials, especially on properties like conductor and insulator. I should insist that if this was an insulator to begin with, and we had done this same process of C going to A and B, nothing would have happened because this redistribution requires that charges move around. And in an insulator, that doesn't happen. So if we had insulating materials, nothing of this would have happened and would have just remained the same as original. With this, let me stop sharing and stop the video.